Hello everyone. In this video we are going to learn the different types of pairs of linear equations, and along with that we are also going to learn how to identify the given pair of equations is consistent or inconsistent, dependent or independent. That depends on the number of solutions after you solve those two linear equations. So let's have a look at it. If number of solutions are greater than or equal to 1, then that pair of linear equation is called as consistent pair. And if the number of solutions are equal to 0, then that pair of linear equation is called as inconsistent. If the number of solutions are greater than 1, then that is dependent pair of linear equations, and if number of solutions are equal to 1, then that is independent pair of linear equations. Now let's have a look at these three types of pairs of linear equations. Everyone must be knowing how to solve this simultaneously. Let's solve this quickly. Then we can generalize this. So in the type 1, first of all, make the coefficient of any one of the variable equal and solve. Let's make coefficient of x equal. Multiply first equation by 4, multiply second equation by 3. So first equation will become 12x plus 16y is equal to 200, and the second equation will become 12x plus 15y is equal to 195. So now let's subtract these two equations. What you will get? You will get y is equal to 5 and you will get x is equal to 10. So after solving these two linear equations simultaneously, we got x is equal to 10 and y is equal to 5. Now we know that every linear equation represents a straight line on a graph paper. So what is this 10, 5? 10, 5 is the intersection point, the coordinates x and y coordinates of their intersection point. So now let's have a look at it. This type 1 is which kind of equations? Let's have a look at it. Over here the number of solutions is equal to 1. So we can say they are consistent equations. Along with that, they are independent equations. They represent which kind of lines? They represent intersecting lines. They are independent pair of equations. They represent intersecting lines. And how many solutions are there? There is a unique solution. So these are the 4 properties over here. Let's do same thing with the second type. You can multiply the equation or you can divide the equation to make the coefficient equal for any one of the variable. Over here you can see that first equation we can divide it by 3, whereas second equation we can divide it by 2. So over here first equation will become 2x plus 5y is equal to 25, and the second equation will become 2x plus 5y is equal to 24. So over here you can see that the value of 2x plus 5y has to be a unique number. It cannot be 25 and it cannot be 24 at the same time. So this is a pair of inconsistent equations. How? Let's have a look at it. If we solve these two equations simultaneously, x will get cancelled out, y will get cancelled out. So over here we will get neither value, we will not get value of x and y. So over here we are not getting the values of x and y, means these two straight lines, they do not intersect with each other. It means they represent parallel lines. So over here what we can conclude is that consistent or inconsistent pair of equations, the number of solutions are 0. So this is inconsistent pair of equation. Is it dependent or independent? We cannot classify this as dependent or independent. They represent which kind of lines? They represent parallel lines. And how many solutions are going to be there? There is no solution or 0 solutions. Similarly, let's try third type, everyone. So over here divide first equation by 3, divide second equation by 2. What you will get? 2x plus 5y is equal to 25, and second equation will also give you 2x plus 5y is equal to 25. So basically these two equations are not two different equations, they are the same equation with two variables. So over here they represent overlapping lines. They represent which kind of lines? They represent overlapping lines. So how many intersection points are there? There are infinite intersection points are there. That is why there are infinite solutions are also there. So this type 3, is it consistent or inconsistent? It is consistent, as number of solutions are infinite. It is dependent or independent? It is dependent, because number of solutions are greater than 1. Now they represent which kind of lines? They represent overlapping lines. And how many solutions are there? There are infinite solutions are there. So now let's generalize these 3 types, everyone. So let's take the first equation is a1x plus b1y plus is equal to c1, and the second equation is a2x plus b2y is equal to c2. So now let's write 3 conditions. The first condition is if a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2, this is which type? This is type 1. Sorry, this is type 2. So whenever this condition is satisfied, the given pair of equation is having no solution. So they are inconsistent pair of equations. They represent parallel lines on a graph paper. We cannot classify them as dependent or independent. Let's have a look at the next condition. If a1 by a2 is equal to b1 by b2, which is equal to c1 by c2, then what happens? This is type 3. So over here, the given pair of equation will have infinite solutions. They are consistent pair of equations. They are dependent pair of equations as well. Along with that, they represent which kind of lines? They represent overlapping lines. Now, if the condition is a1 by a2 is not equal to b1 by b2, it can be equal to c1 by c2, it cannot be equal to c1 by c2, then what happens? This is type 1. So in this case, the given pair of equation will have a unique solution. They are consistent pair of equation or inconsistent? They are consistent. Along with that, they are independent. They represent which kind of lines? They represent intersecting lines. This is how we can identify the given pair of equation as consistent or inconsistent, dependent or independent, and the given pair will have how many solutions when they are solved simultaneously. So depending on this theory, let's try to solve these 2 questions and you can answer in the comment section.